Hello Year 9. The first video this week, as usual, is going to be me going through the answers to last week's homework. So if you haven't done last week's homework, you need to stop right now and do the homework and then come back and watch this video. Okay, so, and also at any point, if I go through any of the questions too quickly, you can just pause it and then go back and watch it again and you'll have another chance to see what it is. So what is a physical change? A physical change is something like a change of state, or a change of shape, which most of you wrote, but then some of you didn't include the most important part. So yes, you can write as a change of state, but you need to include here that in a physical change, critically, no new substance is formed. Okay, and if you don't have that, it's not okay. So you need to make sure that in your definition of a physical change, you're including the fact that no new substance is formed. And a chemical change then is the opposite. So a new substance is formed. So we can have new substance formed. And a lot of you also included that extra bit of information, which is atoms are rearranged. And I went through that in the last video to show how that worked with combustion of methane. What is the name of the process in which a solid becomes a liquid? That is nice and easy, that's melting. So that would be an example of a physical change, because you haven't changed what it is, you've just changed it from a solid to a liquid. What is freezing? That is when a liquid changes to a solid. Is evaporation a physical or a chemical change? It's a physical change, that is the change of a liquid to a gas. So all three of these are all physical changes. Why can gases be compressed? That's because there is, you'll remember in the picture of a gas, I'll just find my picture of a gas here, there are spaces in between the particles that the particles can move into. So you would need to write something like there are spaces between particles they can move into. Okay, look at this chemical equation for the combustion of methane. All right, balance the equation. All right, nice equation balancing question. I won't go through the whole process, but you should have a 2 here and a 2 here. What is combustion? That is when a fuel burns in oxygen. Will this reaction be exothermic or endothermic? Exothermic, okay. Most of you managed to quickly identify that as exothermic because it's combustion, so it's going to warm you up, and a reaction that produces energy, that gives off energy, is an exothermic reaction. How many hydrogen atoms are in one molecule of methane? So one molecule of methane is CH4. Now the little 4 after the H tells me that there are 4 atoms of hydrogen. Is carbon dioxide a reactant or a product? Carbon dioxide is over here, so it is a product. And is the combustion of methane a chemical change or a physical change? Well, I have methane here, but then afterwards I have no methane. So it's changed, hasn't it? Which means that it is going to be a chemical change. I've rearranged the atoms to make something new. Okay. The combustion of methane produces carbon dioxide gas. Describe the distance between the particles in carbon dioxide. Far apart. It's a gas. Describe the arrangement of particles in carbon dioxide. Random. They are randomly arranged. And describe the movement of particles. Okay, fast in all directions. All right, moving on. Let's have a look. Sodium chloride is the name for table salt, the salt you put on your chips. Describe the distance between particles close together. Describe the arrangement, regular. and the movement. They vibrate around a fixed position. Okay, so what I'm saying there is, the reason I've given you those questions is because you need to know, you'll remember in this part, you need to tell me all three things for the three states. So how the particles are arranged, how far apart they are, and how the particles move. So you need to have that information in your mind, memorized. All right, now this is the fun part. Categorize the following processes as either chemical or physical changes. Ice cream melting on a hot day. Physical, nice and easy. That's just a solid melting into a liquid. Steam condensing on a bathroom mirror. Physical. Okay, so, ice cream melting on a hot day, that is solid to liquid. Steam condensing on a bathroom mirror, that is gas to liquid. Okay, that's what happens is all the hot steam, right, when it touches the cold surface of the mirror, it turns into a liquid. So you have here, this is your mirror, all right, and this is your steam particles here. These are H2O. Okay, and when they touch the mirror is cold, so they turn into a liquid on the surface of the mirror. Wood burning, that is a chemical change. That's burning of fuel. All right, you're not going to have the same wood left over afterwards. You have this, this ash. All right, you can't. It's not the same thing. All right, D, sugar dissolving in a cup of tea. This is one I thought that a lot of you would get wrong, maybe. That is a physical change. Okay, the sugar doesn't change. It just dissolves. So you have the solid sugar at the start, and then afterwards you have this sweet tea. But the sugar is still there, and you know it's still there because sugar is sweet. You put it into your tea and it dissolves, and the tea is sweet, which tells you that the sugar is still there, because if the sugar had changed into something else, well, it might not have the same flavour. So the fact that the tea is sweet tells you that the sugar is still in there. You just can't see it anymore. And it's the same with salt. If you put salt into water, the salt dissolves, and if you drink the water tastes really salty because the salt is still there. You just can't see it. So that's a physical change. You haven't made anything new. The sugar's still there. Steam coming off a boiling pot of water is physical, and that is liquid to gas. So the water, it's still water. So you have liquid water and it changes into steam, which is just water in the gas state. Baking a cake. All right, that is going to be chemical. All right, so when you take the cake mixture and you bake it, there's a chemical reaction that happens and it changes into something new. All right, and finally, frying an egg. All right, now this one I think people will have had a difficult time with. Frying an egg, that is a chemical change. All right, and that's because when you fry the egg, I know you might be thinking to yourself, well, at the start I have an egg and at the end I have an egg, so nothing new has been made, but what you have at the start is a raw egg and at the end you have a cooked egg, and so you've made something new there. Now, for all of these, one way that might help you if you had any trouble with these is if you think, how easily can you go in the other direction? All right, so if you look at all the physical changes, those are all easily reversed. Okay, can I turn a liquid into a solid? Yes, I just freeze it. Can I turn a liquid into a gas? Yes, I just need to boil it. Can I turn a gas into a liquid? Yeah, I just need to cool it down. Can I get my sugar out of my cup of tea? Yes, I can boil off the water and the sugar will be left behind. Now, if you look at the chemical changes, those are all really difficult to turn backwards. Can I get my wood back after I've burnt it? No. Can I get my cake mixture back after I've baked the cake? No. And can I turn a fried egg back into a raw egg? Not likely. All right, so that's one way you can help yourself to understand these.